Hello guys, welcome to our channel Dr.MUCOUS. Today we are going to see about action potential. So what is action potential? Why does it takes place? And what are the phases of the action potential? All these things will be covering up in this video. So let's get started with. Okay guys, now imagine this as a cell, and this cell is in the resting state. So what happens to the cell when it is in the resting state? Inside the cell, it will be maintained as negative charge, and outside the cell, it is maintained as positive charge. That is, extracellular region is positively potential, and inside the cell, it is negatively potential. This negativity is maintained by three ways. One is because of the sodium and potassium receptors, which is on the cell membrane, and sodium potassium pump. Sodium potassium pump will be doing is it will be allowing all the sodium to move outside the cell, and it will allow the potassium ions to enter inside this cell. Actually, this is the normal condition. Outside the cell, sodium ions will be present, and inside the cell, potassium ions will be present. To avoid this confusion, we'll go more into the concept, and you will be automatically understanding what the sodium potassium pump is doing and all. Protein ions which present inside is negatively charged, and the size of the protein ions is really large. So by all these three things, the cell intracellular region is maintained negatively potential during the resting state. And this resting state is nothing called as, and this negativity inside the intracellular region and the positivity outside the extracellular region is called as resting membrane potential. The value of the resting membrane potential differs from cell to cell. Like for skeletal muscle, the value is minus 90 MV. For smooth muscles, the value is minus 60 MV. For cardiac muscles, the value is from minus 85 to minus 90 MV. Now let's see the phases of the action potential. First is stimulus artifact, latent period, depolarization, repolarization, hyperpolarization. Now I'll explain each and every term. Stimulus artifact. Just imagine I'm going to prick a cell with a needle. Either you're sitting now and I'm going to prick you with a needle. You'll be sensing something, right? Some signal will be sent to the brain. That first stimulus, nothing but the needle pricking you. That is called as stimulus artifact. It is nothing but a stimulus. And then comes the latent period. It is an isopotential interval. In short, it's nothing but a small interval phase in between the latent period and the depolarization. And the important concept is depolarization, repolarization, hyperpolarization. What happens in depolarization state is, we all know the cell membrane will be containing different receptors, channels, pores and all. So here let's consider this cell membrane is containing sodium channels, potassium channels. What happens during the depolarization is all these sodium channels will open. We know sodium is present extracellularly. So when the sodium channels opens, what happens is all the sodium will enter the cell. So what happens inside the cell? Intracellular region will become positive and the extracellular region will become negative. We all know in resting state, intracellular is negative. now I'm talking about the resting state. In the resting state, the intracellular region is negative and the outside extracellular region is positive. But during the depolarization, what happens? The sodium channels open. When the sodium channels open, all the sodiums are present extracellularly, enters the intracellular region, and the intracellular region becomes positive and the extracellular region becomes negative. This is the condition exactly opposite to repolarization. So what happens in the repolarization? Repolarization is the state where the excited cell, the depolarized cell, has to come back to the resting membrane potential. So what happens there is, in repolarization, the K plus will open and the Na plus channels will be closed. When the K plus opens, we all know K plus will be, potassium ions will be present inside the cell. All these K plus will move outside, making the cell negative inside and positive outside, which is nothing but the resting membrane state. So it will become normal to the resting membrane potential, positive outside and negative inside. Now I'll draw a graph to explain you this in detail. This is the time and this is the resting potential MV. So for now, skeletal muscle, I told the value for the skeletal muscle in the resting state is minus 90. This is 0 and this is plus 35 or something, whatever value you just write there. I just want you to know this is the positive side. Okay, before entering into the concept, I just want to mention about a word called threshold limit. I'm drawing a line. This line is called as threshold limit. So what is this threshold limit? In the name itself is given limit. What is a limit? The stimulus must be efficient to initiate the action potential. There is a limit. The stimulus should cross that limit so that it can initiate the action potential. If it can't cross that limit, it can't initiate the action potential process. So the first state is stimulus artifact, nothing but the stimulus. It may be below the limit, action potential will not be elicited. So it should be something above the threshold frequency. So this is the stimulus artifact. I'm highlighting it. This is the stimulus artifact. If it's below means it cannot initiate the action potential. So it should be higher than the threshold limit. And then the latent period, the resting stage, which prepares the cell for the depolarization. It's very minute latent period, interval state. And next comes the depolarization state. In depolarization state, what happens? Na plus channels open. So Na plus, which are present extracellular, will enters the intracellular region. This phase is called depolarization. So that inside the cell it becomes positive, outside the cell it becomes negative. Next stage is repolarization. Repolarization is nothing but the cell which has been depolarized has to come back to the resting potential, to the normal state, normal resting potential state. This phase is called repolarization. How it comes back to the normal state? The potassium channels open, potassiums are present inside, all the potassiums will move out, so that inside the cell becomes negative and outside the cell becomes positive. This is the normal resting potential condition. Inside the cell it should be negative, outside the cell it should be positive. And what is hyperpolarization? I haven't mentioned there. Hyperpolarization, some of the K plus channels, some of the most of the K plus channels will be closed, but some will be remained open, and because of that repolarization will be continuing, and that phase is called as hyperpolarization. So we all know extracellularly what is present? Sodium ions is present. Intracellularly potassium ions will be present. But if you really understand this concept, you should know this. after action potential extracellularly, because during repolarization what happens, the K plus ions will be moving out. So extracellularly what is there, K plus ions will be there, and intracellularly sodium ions will be there. So again the cell has to become normal, so all the extracellular sodium has to move out and the potassium has to enter in. How it will happen? It's because of sodium potassium pump. It will pump sodium potassium inside and it will pump sodium outside. Thus sodium potassium pump helps in maintaining the negative potential inside the cell. So guys, if you have any doubt, don't hesitate to comment in the comment box, and don't forget to subscribe the channel for further videos. Thank you.